All right, continuing on in our discussion on optimization, we're going to look at example 3, where we have an open box is being constructed from a piece of sheet metal 18 inches by 30 inches by cutting out squares of equal size from the corners and bending up the sides. We want to know what size squares should be cut to make a box of maximum volume. And then we want to know what is the volume. So there's a couple things going on here. Let's first draw ourselves a picture of what's going on. So what we know is we have a piece of sheet metal. It's a rectangle, 18 inches by 30 inches. One side is 18 inches. The other side is 30 inches. Now, what we're doing is we are hoping to cut little squares out of each corner. Now, these dotted lines I'm drawing in should be about the same distance away from the edge. So we're creating squares in the corners, but my drawing skills are not great. We can start by saying that one side length of these squares we're cutting out are x. So all these little squares have a side of x, which means this part right here that I'm going to outline in blue is 18 inches minus 2 x's. So I'm going to write that right next to it, 18 minus 2x. And then in red, this other part, that's 30 inches minus 2x. So in red, we can look at that as 30 minus 2x. Now when we think about volume, if we were to actually cut these little x squares out and fold it up, we're going to have a length, which we can call our blue portion, of 18 minus 2x, a width, which we can call our red portion, 30 minus 2x, and a height, which can be the x's. And volume, we know the formula for volume is length times width times height. So if we multiply those three parts, 18 minus 2x, 30 minus 2x, and x, if we multiply them, that'll give us the volume. So let's start by foiling and distributing everything. If we went 18 times 30, you can do all of that on your own. I'm just going to tell you what we'll end up with. Our volume equation is going to end up being 4x cubed minus 96 x squared plus 540x. So there's our equation. That's our volume function. You can call it v of x. We want to maximize the volume, so we are going to find the derivative of this equation and set it equal to 0. So v prime is going to equal 12x squared minus 192x plus 540. Now if we set this equal to 0, we can solve it for x. Now, you can use whatever method you want to solve this quadratic. You could graph it. You could use a quadratic formula. I'm going to factor because I do notice, and it takes a little practice to get here, everything is divisible by 12. So we're going to have 0 is equal to 12 times x squared minus 16x plus 45. Now, the only way this expression can equal 0 is if everything in the parentheses were to equal 0. So we can just go and set our quadratic x squared minus 16x plus 45 equal to 0. Now, I'm going to factor, but there are no numbers that multiply to make 45 that add to make 16, because 15 and 3, they multiply for 45, but they make 18 when we add them. And 9 and 5, again, multiply to 45, but don't add to 16. They would go to 14. So, we're going to complete the square. As a reminder, what that means is we are going to, I'm actually going to go onto a new screen with this to continue. We could go and add 45 to both sides, subtract it, right away, and that's what I'm going to do. So negative 45 equals x squared minus 16x. Then, what we're going to do is on both sides, and I'm going to do this part in a different color so you can see that it's happening to both. We're going to add half of 16. Half of 16 is 8. But then we have to square that. Remember, that's the process of completing the square. 8 squared we know is 64. So if we add 64 to negative 45, that's 19. Equals. Now, I'm not going to worry about putting the plus 64 on the other side because that's a perfect square trinomial. X squared minus 16x plus 8 squared, because 16 is the same as 2 times 8. So we can factor that right away to the first term. Since the middle term is a minus, we're going to put a minus, and we're going to take the square root of the last term. The square root of 8 squared is 8, and then we square that binomial. So we can now solve this for x. If we take the square root of both sides, we're going to have the square root of 19, and I would say just leave it like that, is equal to x minus 8. Now we can add 8 to both sides, so 8 is going to equal plus or minus, because the square root we know can be positive and negative, the square root of 19. That's equal to x. Now only one of these, 8 plus the square root of 19 or 8 minus the square root of 19, is going to work the best. Now from testing both of them myself by plugging them into our volume function, I know that the only one that's going to work is 8 minus the square root of 19. If I were to go 8 with the 8 plus the square root of 19, we're going to get a negative volume, and that can't happen. Now we can estimate this. So x is going to be about 3.641 inches. That's fine. If you want to be more accurate on your calculator, don't round. So now what we're going to do is, we found the amount. That was one of the things we needed to do. Find the amount that we're going to cut out. The next thing we need to do is we need to find the volume. So we need to find the V of 3.641. And if you want to get real accurate with it, put into your calculator 8 minus the square root of 19. I'm not going to write it all out, but what you're going to find is that the volume is going to come out to be about 886.5 cubic inches. So, what we can say is we are going to cut about, well, cut squares, not cut about. We'll cut squares about 3.641 inches for a maximum volume of 886.5 cubic inches. We're done with example 3. Let's check out example 4. So example 3, we want to know what are the dimensions of an aluminum can that can hold 40 cubic inches of soda, and that uses the least amount of aluminum. We're going to assume the can is a cylinder, or it's cylindrical and capped on both ends. So it's a cylinder. Now, think back to when you were learning geometry. A cylinder is a three-dimensional shape with circles for bases. Those circles have a radius, and that cylinder has a height. There's a formula for finding the surface area. That formula is 2 pi r squared. That part represents the area of the bases, plus 2 pi r times h. That represents the area of the rectangle that goes around the cylinder. The 2 pi r portion of that is the circumference of the circle. Also recall that the volume of a cylinder is found by taking pi r squared, the area of the base, and multiplying it by the height. So let's start by setting our volume equation equal to 40. 40 is going to equal pi r squared times h, and I'm going to actually just solve this for h, because then I can plug that into the surface area equation. So I'm going to divide both sides by pi r squared. So my height is going to be 40 divided by pi r squared. So now I can rewrite my surface area equation. It's going to be 2 pi r squared plus 2 pi r, and instead of h we can write 40 over pi r squared. Now over here in blue we can clean that up. We can get rid of an r, we can get rid of pi even. And then we can multiply. 2 times 40 is 80. So we can rewrite this surface area function. So we can call this S of r, surface area with respect to radius, is going to be 2 pi r squared plus 2 times 40 we said is 80 over r. Now I'm actually even going to go as far as to bring the r up with a negative power, because we're going to find the derivative of this function, s prime. We're going to bring a 2 down from 2 pi r squared. We're going to get 4 pi r plus, we bring a negative 2 down. Now you get not negative 2, that's a 1, negative 1 down. So we're going to have minus 80 r to the negative 2, which let's just go ahead and bring that straight down and call it 80 over r squared. If we want to find a way to minimize the amount of aluminum, now remember the aluminum would be like the surface area of the can, we can set this derivative equal to 0 and solve for r. Now what I would do is I would add 80 r squared to both sides, 80 over r squared. So we can get that equals 4 pi r. Now I don't want r in the denominator, so I'm going to multiply both sides by r squared. We're going to get 80 equals 4 pi r cubed. We're getting there. Now we're going to divide, we're going to solve for r. So we're going to divide by 4 pi. So r cubed is going to equal 80 divided by 4 pi. And we can simplify 80 and 4. 4 goes into 4 once, and 80 20 times. So r cubed is 20 over pi. To figure out what 1r would be, we can take the cube root of both sides. And I would just plug that into my calculator now. The cube root of 20 over pi, it's going to approximate out to 1.853 inches. Now remember, we came up with a formula to find the height given the radius for this can. So we're going to take that and put r in to figure out what should the height of the can be. So if we go 40 divided by pi times 1.853 squared, we can approximate h. In fact, we're going to just plug that into our calculator, and we're going to figure out that h is about 3.707 inches. So the dimensions of our can, we've now got our radius, which is about 1.853, and our height, which is about 3.707. We've got one more example, but it's going to be in our next video.